Alright guys, so welcome back. This is Unit 3, the periodic table. It's going to be actually a really quick unit. So I do expect us to probably be finished with it before Thanksgiving break. It's a very, very, very quick unit. So let's go ahead and let's keep going. One thing I do want you to know is that even though we are now fully remote and we're no longer doing blended learning, that does not stop us. We are going to continue with our daily Zooms and our daily videos and our daily assignments and our quizzes and our homeworks and our exams. And we're going to keep going with our regularly programmed schedule. So let's go ahead and get started with today. So we have this image, right? And I want you to know, what are you noticing between the two? Right? What are you noticing? Now, if you say you notice one is extremely messy and disorganized and one is extremely organized, you're correct. So the thing about chemistry is that we need to remain organized. We need to know where everything is and where everything goes. With that being said, we have a tool that tells us the exact location and the exact placement of each element. And yes, I am talking about the periodic table. So first things first, let me explain how to truly read the periodic table. So, on the periodic table, in your chemistry reference table, I always try to put it with the assignment. You'll notice that we have, if you look on the actual reference table, on the left-hand side, going down, you have periods, and then it goes down. And then if you look between right here, between groups 1 and 2, you have groups, and those goes across. So, our periods are our rows. So, anything that goes from left to right, it was within the same period. So if we look at hydrogen and helium are in the same period. If we look at group period 2, we have lithium, beryllium, and boron on the same period. If we look at period 3, we have sodium, magnesium, and aluminum. If we go at period 4, we have potassium, calcium, strontium, all of these in the same period. So the thing about periods is that if you stay within the same period, you're going to notice, and we're going to look at the electron configuration to make this identification. You're going to notice that they had the same number of energy shells, or they had the same number of orbitals. So if we take a look at lithium and beryllium right here, lithium has 2 energy shells, so does beryllium. And as we go down period 2, you're going to notice that they all have 2 energy shells. Period 3 all have 3 energy shells. Period 4 have all 4 energy shells. So the period number basically tells us how many energy shells or orbitals each element has, right? And then we have groups. Groups are columns, right? So groups go up and down. So hydrogen, lithium, sodium, potassium, rubidium, cesium, and fermium are all in group 1. Then we have beryllium, magnesium, calcium, cerium, barium, and rubidium, all in group 2. As we go on, there's group 3, group 4, group 5, group 6, group 7, right? And then with each group within each group, if you take a look down a certain group, like let's take a look down group 1, look at the electron configuration to see what they have in common. If you notice, they all have the same number of valence electrons. They all have the same outer electron number. Exactly. So, periods are rows, columns are groups, right? Now, the reason why I like the periodic table is because it's set up in a way of playing like Battleship, right? Each element has its own specific coordinates. It has its own period and it has its own group, which is very specific to that element. Meaning, for example, magnesium, if I say group 2, period 3, that's only for magnesium. No other element can be considered. If I say group 1, period 4, you know that's potassium. No other element could be in that period. Another example is if I go period 3, group 13, that's only for aluminum. Nothing else can change its location, right? Or its placement. So let's go ahead and let's try a couple of practice problems out, and let's get to what else we need to know about the periodic table. So we have over here, I've kind of redone a few. So we're gonna do about, let's say, two more. Let's do CA, and I don't believe I have, we'll do K and CA. So we have, so we need to know the group and the period for K. So K, well, K is in period 4 right here, and group 1 right here. So group 1 and period 4. And then CA, let's go ahead and try it out with CA. CA also group period 4, but in group 2. So group 4, no, group 2, period 4. And I do see we have GA cropped in that picture, so let's go ahead and let's do GA as well. So GA, it's right here. GA is in group 13 and in period 4. So group 13 and period 4. Just a coincidence that it's all in the same period, right? So as we keep doing these, each element has its own specific location. Alright, so I'm going to leave you here. You're going to meet back up with me when we talk about the families.